Welcome back, everyone. In this section, we're going to talk about finding relationships in data. Linear relationships and exponential relationships are not the only types of relationships or models that can happen in real life. They might be the most common. Other types include quadratic or logarithmic relationships, but there are many other different types of relationships that occur between data values. If we know the general shape of the data using a scatter plot, we can generally determine the best model in each situation. So in this video, I'm just going to show you how to use your eyes and how to use Excel to determine the best relationship model for whatever data you have. First of all, one of the best tools we have in determining relationships by looking at scatter plots are your eyes. If we just look at these graphs, we can see the relationships that appear to be there. For example, looking at the first graph, we can see that this data tends to form a line. It was kind of like this. So this one is probably linear. In the second graph, we see a curve. And much like the curve we saw in the last section, this one's probably exponential. At the bottom here, we see a line as well, but now it's going down from left to right. This is linear, but it's negative. Similar to both linear and exponential relationships, the quadratic relationship just fits another shape of a curve to a particular data set. Quadratic curves are parabolas, or essentially U-shaped curves. And rather than being x to the first power, like a linear function or a linear equation, quadratic equations begin with x squared. Quadratic relationships are not as common as linear and exponential relationships, but they do occur. For example, the distance that an object falls and the time that it takes for that object to fall have a quadratic relationship. At first glance, quadratic relationships and quadratic curves may look similar to exponential curves. But there's a way to determine which model is accurate, and you already know how to do it using trend lines. So to determine which relationship best models the data, you have two major tools. Your eyes, right? So does the curve that you drew match the data points that you have? And the R-squared value. The R-squared value can be calculated using Excel. So I'm going to show you that the quadratic model is better from the previous set of data by showing you how to find the three different models in Excel. So I'm going to pause for just a second and show you how to do this. So here in Excel we have our scatter plots, and I've just copied it 3 times so that we can do 3 different models. In the first image, let's try a linear model. So if we right click on one of the points, go to Add Trendline, we can choose linear, and then we don't need the equation this time, though you could choose it. Let's just display the R-squared value. And so we can see the straight line, and we can see the value for R-squared. That's pretty close to 1. But let's take a look at the others. If we go to our second image here, we're going to add trend line. But now we want to look at an exponential model. And so if we look at an exponential model, and then display the R-squared value, we can see that R-squared is much less than the linear model. So far the linear model is the best bet that we have. But we can try one more. If we go down to this bottom, we want to add a trend line. Now a quadratic trend line doesn't have its own selections. So let's just do polynomial. Order is just the exponent, so this will be x squared. So a quadratic relationship would be a polynomial of order 2. And then we can display the R-squared value on our chart. And here you can see this is much, much, much closer to 1. And you can also see that the curve fits the data much better. And so if we want to choose the model that's best for the data that we have, we can visually look at the lines that we've drawn and see how well they fit the data. Or we can determine the R-squared value and choose the model that has the greatest R-squared value, the one that's closest to 1. Please let me know if you have any questions.